This video is for students that need to know how to use curvy arrow diagrams to show ionic compounds forming. So this is a practice test that is available in class in print, and the key is also available. Now the key works great for this first part with the vocabulary, so you can go ahead and use it and just fill this in and read it over and study it. But it's going to be a little bit harder when you get to section 2, which is down here. That's telling you to expand the formulas and draw electron dots and arrows. So those are the curvy arrow diagrams. Now the first thing that really helps is being able to read formulas which are made up of elements from the periodic table, and the more you use it, the more you learn to read these. So ionic compounds will always be a metal element and a non-metal element together. All right, you always see one of each in the compound, and the ones we're using on this test are binary, meaning that there's just going to be two different elements in the compound. So let's go through here and underline the elements. Here I have K, which is the element potassium, and C with a straight line after it. That is chlorine. So that is not 3 elements, it's only 2. And you really need to get familiar with the symbol for chlorine because it's a very common element. All right, then we have Ca for calcium, and you'll notice how an element symbol can be a capital and a lowercase letter, or it can be a single capital. So this one is oxygen. Then we have lithium here, Li, and we have nitrogen. Okay, so now I'm going to switch to my board and start showing you how we're going to read these formulas and expand them. So these formulas already tell us the correct ratio of ions in the compound. So I'll start with the first one. That one we have potassium here, and hopefully we're going to be able to see it on the board good there. Yeah, that looks good. And it is in a compound with chlorine. All right, so this is an ionic compound, and the first step in expanding it is figuring out how many of each of these we have. Well, because there's no subscript, we have one of each. Subscript would be that little number that comes after the element symbol and tells us how many we have. So I have 1 potassium, and I'm just going to draw an arrow down here, and this one seems kind of silly almost since we just have one of each, but it's we're just getting used to the process here. All right, and then we have 1 chloride ion also. We call it chloride when it's in an ionic compound. All right, then we're going to look at our periodic table. Oops, sorry, getting out of the screen there. We're going to look at our periodic table, and we have to add our valence electrons because they're the ones that participate in chemical reactions. How do we find those? We have to find the elements on the periodic table. Now, when we're talking about metal elements, we're just going to be dealing with these first 2 columns here, plus the element aluminum, which is right here. All right, so those are the places you're looking for the ones that I have in purple, the metal elements. And you're going to get real familiar with them. So here's K for potassium. Since it is in the first column, all of the elements in the first column have 1 valence electron. And we show that with a dot. And I'm just going to put 1 dot on potassium, like that. Okay, sorry. There we go. And I'm going to zoom out just a little bit here because I zoomed in for my periodic table. There we go. All right, now chlorine, and I'm not going to keep zooming in and out here, so you're just going to have to look at your own periodic table. That's chlorine right there. It's in column 7. All the elements in column 7 will have 7 valence electrons. So I'm going to give chlorine 7 dots. And when we do those dots, if you'll remember, we go around, we do 1 on each side, 1, 2, 3, 4, and then we start to double, 5, 6, 7. Now it's not so important with chlorine because that's really, you're always going to end up with 3 pairs in a single, but it gets more important with some of the other elements. Next thing, we're going to show how that ionic compound forms, which is metals always lose. So metals lose. And so anything on this side of my formula here is going to try to get rid of all the valence electrons. Now it'll still end up with an octet because it loses a valence shell and goes down to the shell below that. But for the purposes of our diagram, we're just going to show it having 0 valence electrons at the end of this process. And our nonmetals gain. Nonmetals gain or win, we can say, but we're going to write gain here. Nonmetals gain, and they're going to try to get an octet, which means 8. So you're not done with the process till you have made that happen. That's what we're trying to do here. So I'm going to transfer 1 electron from potassium over to chlorine, draw it like this, X out my electron on potassium. Okay, so that was my second step, was showing that transfer of electrons. Now my last step is to put on the charges. So for every electron that a metal loses, they gain an additional 1+ charge. So in this case, potassium just lost 1 electron, so it has a charge of 1+. And so these guys are going to get 1+ for each electron. Okay, kind of messing up my diagram there. And these guys over here are going to get 1- for each electron they gain. 1- each electron. Okay, so this guy's going to end up with a charge of 1-. And now that we've put our charges on, our diagram is done. So that's what this first problem here on the test would look like, or practice test. Now I'm going to go over to this one. All right, the next one is a compound, we would call it lithium nitride. I'm going to zoom in a little bit again here. All right, so lithium nitride, the formula is Li with a subscript of 3, and N. That's a nitride ion. All right, so first thing we have to do is expand the formula, right? So we're going to read that formula, and expand means how many do we have of each? We have 3 of the lithium ion. That's what the subscript 3 tells us. It only applies to lithium. So I'm going to draw an arrow like this, and I'm going to write Li 3 times. Okay, on the other side, I only have 1 nitride ion, okay? I'm still going to have to complete that process where I move all the electrons from one side to another. But first I have to figure out how many electrons I have. So you're going to find lithium right here in the first column. So that means it has 1 valence electron. And you're going to find nitrogen. All of your nonmetals are going to be in this little group over here, so they shouldn't be hard to find. Nitrogen's right here at the top of column 5. It's going to have 5 valence electrons. Okay, so I'm going to put in those electrons. Each of these has 1. These are our metals. And then our nonmetal here has 5, but we're going to do that 1 on each side thing. So 1, 2, 3, 4, and then 5. And that's how it ends up. We got 1 pair and 3 unpaired electrons. And each of these unpaired electrons is going to want a partner. So we're going to start transferring electrons over like this. And really, you can transfer any electron to any of these slots, but it usually works out that, you know, to keep your arrows from getting crazy, you kind of do it in order like this. All right, make sure you guys can see all of that. All right, so I'm moving those electrons over. That was step 2. Crossing them out is part of step 2 also. Now all I have to do is put my charges on. So each lithium lost 1 electron. So each lithium gets a charge of 1+. And each nitride gained, or the only nitride I should say, gained 3 electrons. So it gets 1- per electron, but we add them together. So it's the total for that element right there. Okay, so that's a 3-. All right, so that one is done. We're going to do one more for this video And this video is only about when I give you the formula. There's another video for if I don't give you the formula and you have to find that. So that's a little more advanced skill. And if you want to move on to that one, that will be posted as well. All right, so the next compound we're going to look at is on the second page, or it's actually the back of the first page. This is a pretty hard one here, calcium phosphide, but this is going to be a pattern you'll see a lot called the 3-2 pattern. And the solution is always a 2-3 curvy arrow diagram. So I'll show that to you. All right, so we're going to have calcium, Ca, and the subscript is telling me I have 3 calciums for every 2 phosphides. I'm going to draw 1 phosphide here with a little subscript of 2 after it. All right, next step, I read the formula and I draw the correct number of each ion. So for calcium, that's going to be 1, 2, and 3. And make sure that I still in my screen here. Okay, and for phosphide, this time I have 2 on this side. All right, so I'm going to draw those 2, and it will work out, I guarantee it. All right, so we're going to look up where those elements are in the periodic table. Calcium is here in the second column. Like I said, most of your metals are going to be here and here, except for aluminum, which is here. All right, so I'm going to add 2 electrons to each of my calciums. They're not paired because we don't pair until after 4. So it looks like that. And then I'm going to add 5 electrons to my phosphorus. It's right here. So just like nitrogen, it gets 5. 1, 2, 3, 4, 5. 1, 2. Oops, I went ahead and did that one because I knew what was going to happen. 5. All right. Now I'm going to start to move over those electrons. Don't think about it too much ahead of time or you might find it confusing. So I'm probably a little crowded here, but I'm moving this guy over there. All right. And then I'm going to move this guy here. So X these out. 1, 2. And now I have run out of electrons on this calcium. So I just moved to the next calcium. So now this guy is going to go over here, X that out, but now this phosphorus is full, right? It's got 8 electrons, 1, 2, 3, 4, 5, 6, 7, 8. No more electrons for that guy. We're moving down to this one. Okay, so this one, I'm going to transfer this electron here and so on. You can see what's going to happen here. So it all works out. This is going to be, we've got 3 calciums, each giving 2 electrons to 2 phosphides, which each take 3. And so we end up with 6 plus total on this side, 6 minus total on this side, but we're going to write out those individual charges. Each calcium lost 2, so we got 2 plus, 2 plus, 2 plus, and each phosphide gained 3. So that's a 3 minus and a 3 minus. And for any ionic compound, our net charge, that means if we add all the charges on each side together, should be 0. All right, so this is the end of your first curvy arrow tutorial. And the next advanced curvy arrow tutorial will be on when I don't give you the formula and you have to figure it out based on the elements and the charges. All right, good luck. Bye.